Hi, today we're going to start looking at conics and we'll link this to the constructions that we've dealt with in the three previous sections. So first thing we'll talk about is what a locus is. So a locus is a set of points that satisfy a specific condition, and the plural term is called the loci. Now, three common types of loci we've already looked at would be the circle, which is our locus about a point, a perpendicular bisector, and an angle bisector. So first we'll talk about the circle. It's a locus of points that are equidistant from a fixed point to center. So for example, if let's say this dot is the center of a circle, I draw a circle centered on there. And if I measure from any point along the surface of my circle to the center, we should get the same value. So I get 4.7 centimeters measuring that distance. I get 4.7 centimeters measuring this distance. And I get 4.7 centimeters measuring this distance. And so a circle is a locus of all points which are on the outside of a circle that are equidistant to the center of the circle. So, for example, given point A, which we'll call, we're going to construct a locus of all points that are 2.5 centimeters away from A. So what I may want to do is mark how far away that is, or set a compass for 2.5 centimeters, and then we just draw out our circle to that radius, and you should then be able to draw from the center to any point on our outside edge and have it be a distance of 2.5 centimeters. Next, we have our perpendicular bisector. This is a locus of points that are equidistant from two fixed points. So first we'll draw out a perpendicular bisector, and then we'll show how it is a locus of all points are equidistant from the two fixed points. So I'm going to start by drawing a straight line, and then we'll draw in a perpendicular bisector to it. So if you recall, to draw a perpendicular bisector, we're going to want to start by drawing a circle centered on each end of here. Now, those circles have to have the same radius. Now that we have those, we can then draw in our perpendicular bisector. And perpendicular bisectors are locus of all points that are equidistant from two fixed points. So what that means in this context is, for example, if I was to draw a line from here to, let's say, here, and let's measure that. When I measure that, I get a distance of 4.7 centimeters. If I go to the other end of our line and draw it to here to match up where the other line matches, and then measure it, I also get 4.7 centimeters. Now I could choose another point along this line. So for example, if I pick, say, down here, and go to here, and we'll go from here to here, these two should be equal to each other. So that gave me 5.9 centimeters. Now this one's 5.9 centimeters. So any point along this line will be equal distance to either end of the original line that we started with. our third one was our angle bisector. Now this is a locus of points that are equidistant from the sides of an angle. So I'll just quickly draw in what that means. So we'll start out with an angle, then we'll draw in then we'll start working on creating a bisector for it. So you'll recall we start by drawing a circle centered at where our angle starts, and then where we intersect our lines, we'll draw two circles, both with the same radius. Now that we've done that, we'll draw our line from center of our angle straight through those, and we have this angle perfectly bisected. Now we can choose any point on here and if we draw a line that is exactly 90 degrees to it, this distance is going to be the same as this distance. So for example, this would be 2.2 centimeters, and this one is also 2.2 centimeters. Alternatively, I could have done it back over here. And I see that this is 1.3 centimeters, and this is also 1.3 centimeters. So any point along here is equal distance going at a right angle out to one of the arms of our angle.